That's good coffee. Chapter 6, Lesson 5 of Geometry, and we want to look at trapezoids and kites in this video, or in this lesson. Let's take a look at trapezoids first, but before we take a look at the properties of trapezoids or some of the characteristics, there are some things we need to talk about the pieces of the trapezoid. The parallel sides of a trapezoid are called the bases, okay? And then the non-parallel sides are what we're going to call legs. And the two angles that share a base of the trapezoid are called base angles. So to wrap this, or to kind of summarize this particular paragraph, the bases of the trapezoids are the parallel sides. Now this is very important to understand, that it's the parallel sides and it doesn't matter where those parallel sides are. Meaning, in most cases, it's very common for us to think of figures, especially drawn in a book, that whatever is the bottom, that is the base. But it's important to realize that that's not the case. In other words, we need to go by the definition. If I took this trapezoid and I drew it like this, the tendency for most students to think now would be that this is the base. But according to our definition, that's not, because by our definition, it's the parallel sides that are the bases. So this is the base here, and this is the base, even though it's drawn sideways. The base doesn't change based upon how the figure is drawn. The bases are the bases because by definition, the parallel sides are the bases. So just be aware of that. It's very important. Because later on, when we start determining the area of these figures, or even when we're talking about the base angles later on as characteristics, it's important to understand that you have to identify the sides that are parallel to identify the bases. It's not based upon how the figure is drawn. Okay, so keep that in mind moving forward, that by definition, the sides that are parallel are the ones that are the bases. The legs of the trapezoid then would be the ones that are not parallel. Those would be considered the legs. And then a base angle, where the base angles share a base. So this angle here is a base angle along with this one. So these are the base angles along this base. And these are the base angles along this base. Okay, so any two angles that share a base are base angles. Now this angle here, let me do this real quickly. If I'm talking about this angle here and this angle here, these are not base angles of each other because they don't share a base. They're base angles with a different angle because they're base angles here, but they're not base angles of each other. And that's an important distinction to make, and you'll see what I mean here in the next page here when we're talking about the characteristics. Now, the theorem says that the base angles of an isosceles trapezoid are congruent. So going through our classification models, once we establish it as a trapezoid, it has the characteristics that the non-parallel sides are congruent, or if the non-parallel sides are congruent, we're talking about an isosceles trapezoid. Now it's important to understand here that this characteristic that we're talking about, that the base angles are congruent, are only true for an isosceles trapezoid. So it's very important that you first establish whether it's a trapezoid or an isosceles trapezoid before you go to this characteristic, because it's only in an isosceles trapezoid where these base angles are congruent. Now you'll notice again by this diagram, this is a base angle and this is a base angle along this base. These are congruent. This is a base angle and this is a base angle along this base, and they are congruent. What I want you to notice is that these two angles, while they are base angles, are not base angles along the same base. Therefore, they're not congruent. Okay, only the base angles along the same base are congruent. The base angles that share a base are congruent. So base angles are base angles that share a base. These do not share a base. Okay, and so they are not congruent. But I will ask you this: what do you know about these two angles? Anybody know? Anybody remember? These are parallel sides. This is a transversal. Remember we talked about this? So if this is parallel to this, and this is a transversal, these are same side interior, and I'm really scribbling. So, and what do we know about same side interior? Same side interiors are supplementary. So these would add up to 180, even though they're not congruent. Okay? All right, let's look at what else we can know about a trapezoid. The second thing we know, and again, this is specific only to an isosceles trapezoid, and that is that the diagonals, like a rectangle, are equal in length. So the diagonals are equal in length, which is an additional characteristic of, again, an isosceles trapezoid, but only an isosceles trapezoid. One application of this is something that's in your book, and it says that you have this panel of an umbrella that's an isosceles triangle. Now, one thing you want to remember, when it mentions isosceles triangles, it's mentioning that for a reason. I've talked about this before. When we tell you something is a figure, it's because we want you to remember what are the characteristics of that figure, and then you'll need to use it to calculate the values in this problem. The fact that it says it's an isosceles triangle wants me to think back to, what do I know about isosceles triangle? Well, you remember in an isosceles triangle, if these sides are congruent, then I know that these two angles are equal in length. Okay? So we want to remember that. Now, the vertex angle of this triangle is also 42. So it's also telling me that this vertex angle here is 42. And you remember, based upon that, I should be able to calculate the measure of these two angles because, again, it's a large triangle, adds up to 180. If this is 42, I know that these are equal, so I know if I gave, let's say, this an x and this an x because they're the same, then I could write out my equation x plus x, which is 2x, plus the 42 is going to be equal to 180. So then I can get 2x is equal to, let's see, 140, 138. So divide that by 2, so this is going to be 69. So I know that both of these angles here are 69. All right, so, and all of that is based upon the fact that it told me it was an isosceles triangle. Now, you'll notice that if they create this umbrella, if I put that triangle here, and I put this triangle here, and I put this triangle here, I want you to notice what kind of shape is this right here. Well, that's a trapezoid, and it's an isosceles trapezoid, so those characteristics that we were just talking about apply. So if I put this one here, okay, and I put this one here, this is how the umbrella is created, and all of these shapes here are trapezoids. And now you'll notice that down at the bottom here, then, what do I have? And I have an isosceles trapezoid. And what did we just learn about isosceles trapezoid? That the base angles are congruent. And what did I just show you? That those two base angles are congruent. So when it says to classify the quadrilaterals on the blue, those are isosceles trapezoids because these sides are length, these sides are parallel. Find the measure of the interior angles. Now, they want me to figure out the blue one. The bottom one's a blue. I have gold, but this is blue. All right. Well, I already figured out what these two angles are. Now I know, because of what we just talked about, the characteristic that these two angles are going to be equal. I just need to figure out what they are. Well, how can I figure out those? Well, I already know by what I figured out that this is 69 degrees. Okay, let me change that to black here. This is a 69-degree angle. And what did we just talk about those two angles? They're not equal, however, but if those are transversals, I mean, that's parallel, that's transversal, these are same side interior, which means they add up to 180. So this 69 degree that I know, plus this one that I don't know, let's just call it x, are going to add up to 180 because they're same side interior. So x is going to be equal to then 160, it's 160, got to write slower, 180 minus 69, which is going to be, let's see, 7, let's see, I don't even know, 110, so 10, but 101, right? 101 degrees, no, 111. 111. I can't add. I'm trying to go too fast and can't add. So, whoa, didn't want that. So this angle then is going to be 111, which means this angle also is going to be 111. So you can see how we can apply a couple of things that we know, isosceles triangle, along with what we just learned about trapezoids, in order to figure out the measure of these angles.